Okay, now let's come to a very important discussion on how we are going to use these virtual methods in the first place. Okay, when you are writing base star b equal to new derived, I mean, it can have some non-default constructors, so you may be able to pass certain things. So what happens here? So notice here, if I ask what is the static type of star B, so what is B here? So let's draw the diagram one more time. So this is your base class, okay? So base class. So on top of that, you're adding the derived members to it, right? So when you look at the left-hand side here, when you look at the left-hand side, forget about the right-hand side. If you just look at the left-hand side, what do you see is the type of star B?
Is it a pointer to type base?
I'm asking what is the type of star B, not B, right? So
That's
type
the
of star
base,
B,
no?
base. Base is the type, right? So B, as you said, is a pointer to base, and therefore star B is base, right? The static type is base. So what is the dynamic type of star B?
Wait, can you clarify again the static and dynamic terminology?
Right. So remember in the first lecture we discussed, the static is when the allocation goes to the which section? The stack section, correct? And
versus heap.
and
Or
the dynamic is coming from the allocation on the heap. So here B is allocated on the stack, the pointer, right? So B points to what? When you ask the question, B points to the base, right? So if you ask like, what is the static type of star B? It is the base. But what is it at the runtime this B is pointing to? You have to look into the right-hand side of this equality. So when you look at the right-hand side, it is allocating some space, right, in the heap, right? And what is the type of that? So when you're doing a new operator, right, that is immediately this tells you that you're allocating on the heap, right? So this is dynamically allocated memory. So what is the dynamic type of star B here?
derived.
Exactly. So
wait, so it's both static and dynamic.
So star B has a static type as base, because it is, after all, when you have defined this, so in order to find the static type, you look at the left-hand side of the equality, right? If suppose I had split this in this way, okay, it's probably you're having a difficulty. If I have written this first, I can write this, right? And then later on, I go and then write down new derived. Now you can see this, right? So if I ask at this point, what is the static type of star B? What is the type of star B? It is the base, based on this. But then dynamically, I can, because it's a pointer, it can be made to point to anything. It can be made to point to anything that is actually compatible with its type. So why is this compatible here? Because remember, derived is first of all a base class. And that is why it is perfectly okay for me to say that, okay, B is now at this point going to point to the section of memory that is allocated on the heap. And that dynamic type here is derived. So please try to understand this point. Okay,
so it's basically
if you understand this point, the rest of the understanding will become very clear.
Wait, so just to clarify, so like for the first line, the base star B, that kind of allocates memory in the stack of
Well, we discussed, right? When you just have this, right?
Mm-hmm.
This is stack.
But then, so you're saying like, but it points to a derived class memory in the heap as well, basically.
So this is the derived. This is the derived allocation, right, in the heap. And this is basically saying that B points to this guy, right? The pointer itself is allocated on the stack, correct? So statically, so what does it mean by static? Static, I mean, static can mean many things. So when we are asking in the context of type, right? Static means what you can determine at the compile time. So what can compiler say about this when it is processing it? It can only see that, okay, type of B at the compile time is base. But at the runtime, it can point to different things. So here, because of this statement, at the runtime, it's going to point to the derived. Okay, so if you understand this, right? Now, when we write down B F1, okay, what is this going to invoke? So we are asking the question, B, after we have defined this, okay, I'm calling F1 on this object pointer B F1. So question is, which one is it going to call, this F1 or this F1?
Does it matter because it can't be overridden, right?
No, it cannot be overwritten for F1. So therefore, we need to be absolutely sure which F1 is getting called because it is not overwritten.
Would it call the derived F1?
So notice here, because this F1 cannot be overwritten, and therefore, when we are asking the question, what is this F1, which F1 is going to be called, this is going to invoke the base F1. Why? Because that is the static type of star B. But if I call B F2, because it is virtual, it now looks into the dynamic type. So in other words, the non-virtual looks into the static type. And virtual functions look into the dynamic type. So when you ask this question, now B F2, B pointed, B, the F2 of B, this is going to invoke. So it's going to look up, okay, what is this dynamically pointing to? It is pointing to the derived, right? So therefore, you should call the derived F2. Why? Because f2 is a virtual function. And if I likewise do f3, same. So it's going to call derived f3. Is this point clear?
So
this,
the non-virtual functions are called in the base, whereas the virtual ones are called in dynamic.
this is the key point, that non-virtual functions are called on the static type and virtual functions are called on the dynamic type. So at any given time, you have to see what is the static type of this. So if I had written just straight away base star b equal to new base, right? Then both the static and the dynamic type is base type, right? So there is absolutely no doubt that it's going to call all with respect to the base. The question only arises when you have this kind of situation where base star b equal to new derived. So one may ask, why would someone do something like this? But this is the beauty of the polymorphism, because now let's look at this animal example. So I may have derived, let's say, dog and cat, right? And I can write animal star a equal to new dog. Okay. So I can say a eat, right? So today I'm having cat and dog in my list of animals, right? So when I'm doing a eat, of course, I would like to qualify that dog, the way the dog is going to eat, or the kind of things that the dog is going to eat may not exactly match what cat is going to eat. And therefore, this is a perfect example where I would like to have eat as a virtual function here, right? In fact, I may like to say that, okay, this should be a pure virtual function, because just animal in itself cannot really qualify how to exactly eat and what to eat. It really depends on the species. So therefore, I make it mandatory for this method to be overwritten. And therefore, the dog has to define eat. The cat has to define eat. And any more animals that I add in the future, they also have to define eat. So tomorrow I get a cow. So that also has to define eat. So this kind of way of creating a static type with respect to the base class gives me a flexibility for A to be pointing to any new species in the future without my worrying about how to deal with it. Because all I need to do is that I just keep on extending. As long as I define this as per this new species, I'm perfectly fine. And the program is going to be fine. I mean, if I replace this dog with a cow now, the program is not going to have any problem whatsoever. Because by having this virtual eat here, I have made sure that every new species that comes into picture, you have to explain how that animal is going to perform the eat function. So this is the achievement of the polymorphism. Questions?
I have one like syntactical question.
Go ahead.
Do you intentionally, when you go down a bit, did you intentionally put the parentheses after, for example, new dog, even though it's not really a method? Because like, isn't it like a new dog is like a instance of animal, but it's not really a method, right? So why does it need the parentheses there?
This is a syntactically important statement to indicate that if it doesn't, I mean, in one sense, when you just have a default constructor, you may or may not need to have this open bracket, close bracket. But if you have a non-default constructor, let's say whenever I'm, this is invoking a constructor here, right? So when you're invoking a constructor, there are certain initialization opportunities you're getting. So therefore, non-default constructor is just allowing you to provide those initialization parameters. Like for example, I want every animal to be instantiated with its name. So I can say Tom, okay? The dog is called Tom, for example, by passing in a parameter. So therefore, even when there is no parameter, like in other words, when we are invoking just the default constructor, it's better to always write down open bracket, close bracket to indicate that I'm calling the default constructor. Is that clear?
Okay, that makes sense. Thank you.
Okay. Any other question? We introduced a very important notion today, this inheritance.
I'm sorry, Professor, just for clarity, could you give an example in the same, I guess, line as the B and F1, F2, F3 of
Okay.
where the F1 of the derived would be called?
Sure. When you will be having derived star D equal to new derived. So as I said, for the non-virtual function to be called, the static type has to determine that. So you look at the left-hand side. For dynamic type, you look at the right-hand side. Is that clear?
Yes, thank you.
I mean, you can make it more interesting, like in the sense you can have base from where we derived. From here, we can derive another one. Derived. Two, let's say, right? So you can make the whole hierarchy arbitrarily complicated, you know? So therefore, in order to be 100% sure, you have to come back to this way I have explained to you. Ask yourself this question: what is the static type? Based on which all those non-virtual functions would get called. And likewise, what is the dynamic type? Then the virtual functions would get called. It's as simple as that. So as long as your analysis of that is clear, you can never get wrong.
Professor?
Yeah.
Does any function you want to use in one of the derived types have to be like stated as a virtual function in the base? Like, can you create a fully new function in one of the derived, or does it have to originally be like a virtual void function in the base?
No. I mean, if you want something to be overwritten, right? Only then the question of virtual comes into picture. You can have arbitrarily any number of functions here. You can have void f4 here, which does not exist in the base class, which is perfectly fine. The key for the virtual keyword to exist is to bring up this point that I want this function to be overwritten by my derived classes. So the call is made by the higher level class, whether something is a virtual or not. And as far as the non-virtual functions are concerned, you can define as many functions as you like. So from the point of view of the derived class, the question would be what I would like my derived classes to be overriding, and based on which I will decide whether I'm going to put a virtual keyword before this new F4 or not. Is that clear? Daria, is that clear?
Yes, that is. Thank you.
Okay, good.
Wait, so I have a question, another question.
Okay, go ahead.
So can you go down to the eat thing, the eat
Yeah,
method?
sure.
So would it be, if you have to overwrite it, right, to tell what the animal's eating, like wouldn't you have to pass in like, I don't know, like dog food, for example, like in order for it to like know exactly, like would it be wrong to just keep it like that,
Well,
to keep it just
I mean,
eat
it all
what you
depends
see?
on the implementation of the dog, right? The dog may carry certain instance properties, which has a lot of information about eating. So, maybe the dog is just self-contained. It does not need any inputs from the outside to provide the details about how it is going to eat, you know? So the dog itself can have in the member the dog food aspect. So in which case,
But like you see, we have to overwrite it, right? So like I don't understand, like,
you're overwriting the function, but you're asking about, do I need to pass parameter or not, right?
yeah.
Yeah, I'm talking about that is totally dependent on what kind of information is being maintained by the class, whether it has got all the information necessary in its own instance to carry out the eat function.
Wait, could you give like a quick example of that? Sorry, I'm a bit confused.
Yeah, sure. So you're talking about eating here, right? So you can say here, for example, class dog colon public animal, right? This is how you're going to derive. And then suppose in the private section, I have got a new, let's say, I have a new class instantiation called dog food df, okay? And I have a class dog food detailing all about the nature of things that the dog can eat, you know? And then in the public section, here comes the virtual method. So virtual void eat, right? So now when I'm defining, so let's say outside the class, then I will say void dog colon eat. And then here, I just have to invoke essentially, I mean, if you want to show the dog eating, you can say cout less than df dot item 1 and so on and so forth, you know? So my point is that it all depends on how exactly the class has been designed. If it has got information about whatever it needs to do to carry out the eat function, it does not need anything from outside. Does that make sense?
Yeah. So okay, so the part on the left would be in like the .h file or whatever, and then the part on the right would be, you're kind of, I mean, it's not a constructor, but you're kind of like
I forget the
eat
syntax.
is, wait, so it's there, it says cout and then dog item 1,
Yeah, I mean,
or
here,
dog food
I mean, I'm just here making things up here in front of you. So suppose eating from dog side is all about just printing out the list of items that the dog is just putting in its mouth, right? So in the private section, you may have different varieties of dog food, right? So you probably has listed, let's say, string item 1, right? String item 2, you know? And then in the public,
Mhm.
you have exposed this string item 1 as a method to return, right? this item 1 from here. So then now it can actually just print out whatever items you have put in there.
Okay, that makes sense.
Yeah, I'm just pointing out that it all depends on the context. Like it depends on the type of implementation you have to figure out whether it needs any input from the outside or not. And therefore you cannot like generalize it.